Hey everybody, today we're gonna look at different implementation of AutoGPT, which writes code, debugs it automatically, all while using documentation as its guidance. What we're gonna do is we're gonna load this page, this URL, question answering and summarize, analyze document URL, and character text splitter from langchain. And then we're going to ask, and we will be using a Python agent with the Pyton Repl, which is able to execute code and gets feedback from the output and takes in user instructions to write code, whatever you like. Let's just run this. The best way to understand it is to see it. When we run this code, we are first greeted that this script will be auto-executing AI-generated code. This may be dangerous. Make sure you're observing the process. We have to say accept here. Once we type in accept and click enter, we are asked, do you want to load any URLs? We're going to say yes. We don't have to load URLs if you don't want to. You can just give it instructions without the URLs. I've set it up so that you can load up to 3 URLs. We are first going to load the URL for analyze document. You simply paste it in the terminal with right click and enter. And then the second URL is going to be the character splitter. You're going to copy that and paste it here and click enter. We don't have a third URL, although you could. So to skip that, I'm just going to press enter. So now this process is going to take a moment. We are using GPT-4. So there's 3 parts to this process. So while this is going on, I'll explain what's going on here. But we are getting content from URLs, but in a particular way. We are not getting everything. We are actually sending the URLs to GPT-4 so that we get the most essential parts. What's happening here is that we are using PlayWright's URL loader to actually get the content from these URL links from the pages. And then we are making a vanilla OpenAI call to GPT-4 with that content, and we want to extract from that content only the code and other crucial information, but we don't want to also lose any content either, right? For example, if you just take a look at this page, character text splitter, there's some essential content such as these instructions right here, but there's also like some example text. But what we really need is like this code, right? This is what can really give us how to implement the character text splitter. Now the idea is that these documentation pages can be quite long, okay? And if we were to just take all of this and stuff it into the GPT-4 then and expect to get a code written for us, we might just run into token limitation errors. So that's why I crafted this system where we are first sending to GPT-4 to get this documents analyzed and get the most valuable information out of them. And then we receive the response. And after we receive the response, as you can see right here, we have received it. See, we have received the essential code. So I do warn here that review the content. If the content doesn't represent the contents of the original URL, then rerun the script. And as we see here, we have the QA chain and the text splitter. We just need to make sure that essential elements are here. That's why you do have to look over the documentation and kind of get a sense of what you all need. And this runs 95% of the time perfectly, but sometimes not. That's why you have to review it. In this case, it didn't. I'm going to run it again. So we are doing our second attempt. In the meantime, let's continue. So we do want to get the essential information. Once we have that, then we're going to go ahead and actually make a third call with the Pyton Repl tool, the Pyton Repl agent. And with the multi-line input, we are going to be able to input some instructions, and our instruction is going to be use the Isaac Newton text file here. This is a redacted version of the Wikipedia article for Isaac Newton. And we're going to say split the text into 500 character chunks with no overlap and only use the first chunk in the QA chain. See, we don't want to summarize. We do want to use the QA chain. Use the stuff chain type. User will be interacting with it in a chat-like format. And if we take a look at the documentation, as we see, actually, in the question answering, stuff, nowhere in the 2 pages, stuff chain type is mentioned. It's only using MapReduce. And we're not going to be using summarize. We're saying only question answering, QA chain. We're not even specifying the exact name. And also with the character text splitter, we're saying chunk size of 500 and also overlap of 0. And this will, of course, split it into multiple pieces, but we said that we only want to work with the first element of that first chunk or the first element of the list. So as we see, so we review it, we have the summarize elements, we have the QA elements and the text splitter. Once we know we have all our elements, all we have to do is just put our instructions in here. I have implemented multi-line input, so you can actually paste code here as well. Because it's a multi-line input, we do have to say done and click enter. And now we're entering agent executor chain. So this is the fun part. As you see, I have heavily modified the prompt so that this actually works as well as we hope. First, I need to read the isaacnewton.txt file, split it into 500 text chunks with no overlap. I will use the first chunk in the QA chain with the stuff chain type. And then it goes on explaining what it needs to do. Creates a requirements list. It doesn't do that. I have instructed it to create a list. A dictionary. It doesn't always do it, but essentially that actually helps it by following the user instructions like step by step. So here it specifies our file, chunk size, overlap, chain type, and interaction type continuous chat. It runs this and it runs into a syntax error. And it's going to try to use a print statement to identify the problem. Let's see. I will pause the video. We are using GPT-4 for this as well. So it's pretty slow. I don't want to bore you, but I will pause the video and come back shortly. While it is ongoing, let's actually examine the text, the code it has written. So it is opening the Isaac Newton file as expected. It is using the character text splitter with chunk size 500, chunk overlap 0, and it splits it. So everything is fine up until here. And then it's using the first chunk element. This is correct. And it's trying to print the first chunk just to see if it has any problems. It had run into the same error. And then it's loading the QA chain with the stuff chain type, which we have specified. This is correct as well. Here it's making a mistake because this accepts 2 arguments, input document plus the user question. So let's see what it does. Just want to mention the echohive AI Academy I have created. So far I have made over 130 AI coding videos. So I created this app so you can just search it instantly, find the right videos for you, take a look at descriptions, or find the code download from Patreon. It just makes it convenient. It's echohive.live. Link will be in the description. By my last attempt, it did get stuck in a loop because the error statement was a little bit vague, invalid syntax. Actually, I couldn't even really understand why it was given this error. The code was mostly right. It's 95% there. All you have to do is just add .page content over here and add a user question, and you're good to go, which would have taken someone maybe longer to try to figure out from the documentation alone. So as we see in the first interaction, it actually received an error. See, set the sequence up. So it actually did really well this time, but it got the expected string because it had a problem with how the character text splitter creates the document, because it's a tuple. So it actually decided to print it. See, as you see, it actually prints it. And then it understands that it has to use page contents here. Let's see, it says I can see that the text variable contains a list of document objects. I need to extract the page content. And here it's actually using that text, first element of the text, the page content, versus up here, when it was receiving the error, it was only trying to, let's see, where is it? It was only trying to use the first element, which is the tuple object right here, right? A list, a tuple within a list does. Because at the end, there's some metadata. Actually, on the third try, see, it was able to create a code that actually worked perfectly. It actually was able to get the answer right. Now it's actually giving us the final answer. But we can just copy this, for example. You do have to run this in an environment which you have all these packages installed. We're going to talk about the requirements here in a moment. But if you were to bring it into this test and just run this, you see, we are loading our QA chain, text splitter. We are loading isaacnewton.txt and getting first chunk is the first element's page content. And we are inputting that as the document. And question is, what did Isaac Newton discover? We run it. Oh, I have to stop that. And when we run, this is actually a working code, langchain code, question answering over documents. Is we have split the documents into 3, but we are only using the first document, and Isaac Newton discovered the laws of motion and universal gravitation. So I found that this works really well. In my testing, it worked almost perfectly, like 3 out of 5 times, and the other 2 times it gives you the code. It gets the code there like 90 to 95, 80 to 90%, and you just have to do a little debugging And when we run this, I just want to show you real quick before we talk about the code that you don't have to input URLs. You can just say no here, and you can just give it your query right here. For example, I'm just going to say write 3 for loops within one another, which multiplies numbers. Actually, let's use this example from the documentation. So we're going to ask code a 3-neuron neural network and train and test it with a synthetic data set for x equals 2y. You have to say done. And we are entering an agent executor chain. So it's going to say, first I will create a dictionary to store the user requirements. And I will create a synthetic data set for x equals 2y. After that, I will create a simple 3-neuron neural network. In the example, it was actually a single neuron. Anyway, finally, I will test the neural network. It's creating the dictionary. It doesn't always do this. We'll have to talk about the imports. This is the prompt, which I have heavily modified. See, I've asked it to actually use a dictionary style, so it keeps better track of its progress. But anyway, here it's creating a synthetic data set using NumPy. It is importing NumPy, that's good. Creating input size, hidden size, output size, okay. It's initializing the weights and biases, that's good. So you're going to use the sigmoid activation function. It's going to train it. Let's see what happens. This is interesting. So you don't have to load URLs, but the beauty behind the URLs is that you can really do some searching ahead of time yourself, find the necessary documentation of what you need to do that relates to what you need to do, and just use those URLs. I know this is not as automated as using similarity search over a vector index database, but those really don't work perfectly well, and I'm going to actually demonstrate it to you with GPT-4. I have access to browsing with GPT-4, and we can actually try the exact same thing we tried at first, right after this neural network demonstration. So look, so it finished it and ran it. There we go. And test input. I have successfully created a synthetic data set, and it's given its final answer. Yeah, it's pretty crazy. So let's just grab our instructions without any links and give it to GPT-4 and see how far it goes. See, it didn't even know what to do, but I have added return a Python script for this. Let's see what it does now. As we see here, we got some code. Loading of the text is fine, but there's nothing about langchain. It just simply doesn't know what langchain is. It doesn't know what a QA chain is. It's just trying to come up with something cool as far as it knows what's best. But this is not what we were looking for. By the way, we're going to review the code here in a moment, but all the necessary code will be available to my Patreon supporters. The link will be in the description. Now let's try it with web browsing with GPT-4. This uses GPT-4, and it is capable of actually browsing the internet and going to URLs and whatnot. Again, let's just give it our instructions and see what it does, because it is able to search the internet. Again, it neither searched the internet nor gave us a right answer. So I am adding search langchain documentation and write a Python script for these instructions. Now it is actually browsing. Let's see what it does. It clicked on a link. Which link? It clicked on the main welcome page. Clicked on a second one, which is the same. Fourth one, API references. So it's not really text splitters. Okay, it's getting close. It went to character text splitter. Okay. It clicked on this link. Okay. Isn't this the JavaScript documentation? It got the chains. Not sure what this is. So I clicked on 2 more links. This is not loading. Character text splitter again. Let's see what it does. So it says, however, I wasn't able to complete the research and find example. It refused to do it. So this is twice it failed. Let's actually try to give it the links. Okay, so I'm giving it the instruction. We're using web browsing with GPT-4. I'm giving it the instructions that browse the following links, the 2 links which we have used with the autocoder, and write a Python script for these specifications. Let me fix that. And this was our instructions. Let's see what happens. So it is going to try to browse. And it clicked on the analyze document. That's good. And it clicked on, again, analyze document. Clicked on another link, transformation chain. So this is not what we need. It's kind of getting sidetracked. So it's clicking on links which we don't need. We clicked 4 times on transformation chain. Okay, it did find the character text splitter. Let's see what it does. Okay, so this is not, so this is the coded route. This is not correct. This is not correct either. Text index. There is no such thing as text index. I don't think so. I tried this before too. It can do very well, but not in this case. So I'm saying this code works better, I think, than similarity search over a large vector database. All you have to do is just, for example, if you're dealing with langchain, just browse the documentation. Look for what you need. Like maybe you need to use memories, indexes. Find those URLs, enter it, come up with a really good pinpointing, detailed and clear instruction set, and see what it does. I found that this actually works really well. I'm going to be using this on my own development endeavors. Now let's start reviewing the code. Like I said, this code will be available for my Patreon supporters. This code, there's 3 essential parts to this code. One is use the PlayWright to get the contents out of the URLs. And then the vanilla API called the GPT-4 to get the essentials out of that content so that we are saving on tokens and keeping the model on point. And then to run the Pyton Repl agent chain. And then that's it. Requirements for this is OpenAI, langchain, PlayWright. So you have to pip install PlayWright, and then you have to pip install unstructured. That's all you have to do. And then after you've installed these 2, then you have to run the PlayWright install in the terminal to install the Chromium browsers. It automatically installs, it installs 4 different browsers, I believe. So you just have to run this command. You do have to do this. You have to install tick token and term color for colorful printing in the terminal. So these are it. This requirements file will be available at Patreon as well. And then we have our imports. We have our imports.py file where we have our prompt template and 2 other classes, the class prompt template, and then the custom output parser, which we are importing into the browse.py. So this is our main file, and this is our auxiliary file, maybe utilities, you might call it. This prompt template is heavily modified. I'm not going to read all of it, but you can read it. I'll slowly scroll. So this is designed so that it will try to execute the code step by step. Doesn't forget any of the user requirements, hopefully. And when it's trying to debug, it will mostly heavily rely on the print statements rather than coming out with random suggestions to itself. And then obviously, then we give it the example. It has to have a thought and then an action, observation, thought, and eventually a final answer. Custom prompt template is just a class from langchain to actually initialize the prompt with the agent scratchpad tools and whatnot. And custom output parser is to be able to parse the output of the model once it's done or while it's actually executing step by step. And in our browse.py file, we're going to be having those imports a little bit somewhere down here, right there. But before we get there, what we're doing is we first import the PlayWright URL loader from langchain, OpenAI. We are importing OS, not using it. We can delete that. We are importing colored from term color. You do have to define your API key, either from an environment or you can just define it right here in the code. Okay. And then I'm actually asking user to be careful with this because it is auto-executing AI-generated code. I just want to be cautious. Then we have a function to get the URLs from the user, just like this. One by one. I am limiting the number of URLs to 3, but feel free to change it. The reason why I limited to 3, because if you load in too many URLs, then you're going to start running into context limit problems of the model. And then after that, we are getting the contents from URL. This takes about, depending on the how much content, it takes some time. It's not too long though, maybe a minute maximum. And then we initialize the loop while true, so we can interact with the agent continuously. We get the URLs using that function we have defined up here. Then we load those URLs with the PlayWright URL loader. We do check if there are user URLs because user don't have to enter URLs. And I forgot to mention that we do ask right here in the function, do you want to load any URLs? And if there's not, then we'll skip this part. If there is, we'll load those URLs, we'll turn them into data, just make a separator in between them. And then we make a call to OpenAI by giving the content, combined content, because we are combining the content into a single element. Content that is provided, instructions, we want to summarize exactly the necessary information and code out of it, right? Then we print it to the terminal and we ask the user to review the content to make sure that essential elements are present. And we do the necessary imports from langchain. And then from imports, the file that we have had our two classes and our prompt, we are importing the two classes plus our prompt template. Then we define our Python coder with the Pyton Repl tool, which we have imported right here from langchain. This is the Python executing agent. This is the syntax to define it. Python coder is a tool that runs Python code. Okay. And our template, which is going to be the prompt template, which we are importing. And we define our prompt template with the custom prompt template class. Our output parser is going to be the custom output parser, which we are importing from the imports.py. And we are making a chat OpenAI call to GPT-4. I do recommend using GPT-4. I did use 0.1 temperature, so it doesn't get stuck in loops so much. You can experiment with it. I haven't seen this model get stuck in loop all the time. Maybe it gets stuck 2 out of 10 times. So it's not perfect, but I believe this is definitely an improvement to already existing systems I've seen. And we've defined our LLM chains. We define our tool names, right? We are only using one tool, which is the Python executing REPL. And we are defining our agent, like the LLM single agent. Right? This is our chain output parser. This is our stop token. Tools are allow tools. And our agent executor is from agent and tools, agent tools, verbose true, so we can actually see its thought processes. And then we have a get multi-line input function, so that we remember when we are asked for what Python code we want to write, then we are initiating this, so we can enter as many lines of instructions as you like. You can paste entire lines of Python code right here. The only thing you have to do is when you're done, you have to write done in a new line and click enter. So this is what it does. It gets user input. Just like this, we ask, what would you like to code in Python? Type done when, and then enter when done. And we are calling it with this function. And then we simply just run the agent executor chain with the user input. So that's it. Maybe I'll do a live stream one of these days, testing it more. I don't want this video to be so long. Maybe I'll make another video on this too. This was really exciting. I hope you'll find it useful. Like I said, the code will be available at Patreon. Link will be in the description. Come chat with us at the Discord as well if you like talking about this type of stuff. If you like to work with large language models and build apps around them, we would welcome you. The link will be in the description. And thank you for watching. See you in the next video. Just want to mention the echohive AI Academy I have created. So far, I have made over 130 AI coding videos. So I created this app so you can just search it instantly, find the right videos for you, take a look at descriptions, or find the code download from Patreon. It just makes it convenient. It's echohive.live. Link will be in the description.